No. Dude, the working 2 jobs and going to school full time is starting to catch up to me.
Yeah.
Oh, yes.
I can't.
I feel like we probably all at least have one job, if not 2.
Yeah.
Because we all do a lot of online stuff.
Well, mine
Updating your social media doesn't count.
I actually don't have social media. Thank you, Dr. Prather. And you want to know what? You inspired me to delete it. I'm not gonna lie. Because last semester, before I stepped into your classroom last semester, I was really debating on whether or not I should delete social media. And when y'all walked into your classroom that first day, you were like,
you don't have
"It's
such.
so bad."
Yeah.
I'm like, "That's my
There
sign."
are only downsides. There is
I
no
know,
upside.
and I agree with that 100%. That's why I deleted most of it. I do still have TikTok. Okay? I can't get rid of that. Yeah. I gotta have something to scroll on, you know what I mean?
That's okay.
Doom scroll.
There are places on the dark web where I might show up.
Please stop. Oh,
I
God.
believe it.
Yeah, for real.
Where do you think you got the crickets from?
That's what you can get those. You don't come from the dark web. Okay. For real.
I don't have enough time for anything. I'm done.
You're back.
You're 26?
Oh.
I didn't know that. You look like you're 19.
Thank you, girl.
That's
You know,
crazy.
That's what I said.
Black don't crack unless
Oh, what happened?
Yeah, my boyfriend, he's like 20, and everybody says he looks like he's like 16, 17.
Well,
I'm like, dude, I'm not pedophile, okay?
unless you do crack, and then it'll crack.
Right. Right.
Other than that, we pretty good.
Oh, damn, I'm scared to ask
I
now.
could not believe you were.
How old do I look?
26.
I'm
I'm a substitute
29,
teacher.
30?
I'm a substitute teacher,
Oh,
and I
right.
got yelled at for like
40?
being in the wrong line.
Huh?
Cause I was
Wait,
in, like
what?
the staff line. I'm a substitute teacher, and I got yelled at by one of the staff for being in the wrong line. They thought I was supposed to be in like the kids line. And I just looked at her and I said, "Is that how you talk to your students?" But now we laugh about it every time. But I'm just like, yeah.
Mm-hmm.
Alright.
40?
You do not.
You 40?
That's what I said.
Girl, hey, you don't do crack, do you?
No. I never been a fat crackhead, so I definitely don't do crack.
Fat crackhead is funny. I think
Wait
we
a minute for
missing
Caitlin
one.
Gator.
Yep, I'm there. I think we
Oh.
missing- Oh,
She left. She said, bye, I'm going to take a nap and
She
get
did.
food and take a shower. She done told me that.
Hallelujah.
I did when she
Couple
walked
of
out.
that with some of that stuff. Oh, can I have my calculator back?
oh, of course.
No.
I think it made me smarter for real. I'm gonna hope that it didn't eat it. Cause I was like, oh, okay, I'm getting it.
You know,
I'm
it's
sure you
expensive. I can't lose this electronics.
Right.
Oh, I'm sure.
I'll trade you a pack of
That
crackers. for
calculator
thing.
is twice as old as I am. I guarantee it.
Probably.
Because my mom has those same ones in her classroom, and they're from like 80 something. So.
How did you get into substitute teaching?
Girl, I needed a job. I wanted a job though that I could pick my own schedule, and it's so flexible. Like I didn't go to work for a
How do
whole
you?
month.
What do you do it? What? How do you? Did you
Apply at Hardin County Schools.
Oh.
And it's just gonna go by your credit hours, and you good.
Oh, cool. I want to be a teacher. I want to be a teacher, bro. But they don't make good money.
Listen, I work in an MSD classroom as an assistant, and I get paid $11.99 an hour. I make 15 at Culver's.
Yeah,
That's why I couldn't quit.
I make 15 at Honey Baked Ham.
Literally, like it's ridiculous.
Anybody that works in an elementary school after I took my son's dog for show and tell,
Uh-huh.
I praise y'all because they're interrupting that class every
Girl.
3 seconds for something.
Oh,
It's
just like
Pulling their
us.
student out. I'm like, how do they learn?
Imagine that.
I just exactly. I just look at them though. Like I just stare at them like for a long time, and they say, "I think we need to be quiet," and I'm like,
there you go.
"Mm-hmm."
Okay,
I
we're
love
back.
it.
I think. Oh
Nope,
shoot!
that.
She did that on
Oh my
purpose.
god.
You should like grade the papers right now.
You know, we could just go home. We just
Nah,
go
I'm
nice.
gonna use another 20 minutes.
He wanna teach us two-way and Nova.
Yeah, he wants to get to that. Are we gonna get to the damn two-way in Nova?
Mm-mm.
Thank God.
I need time.
We may have a couple of
Parabola.
assumptions we talk about.
Oh, whatever.
I like talking about stuff,
I like talking about it, but
but not being tested on it. Talking, I love the interesting conversation.
oh gosh, there's a
No,
parent.
literally, I'm so proud that I've kept up with this piece of paper for this long.
Yeah, I'm
It's
proud
been
of
like
this
3
paper.
months. Thank you.
You're welcome.
Since he won't say anything back to you.
Thank you.
Here's the mean guy.
Did you just see?
He just roll his
He said-
eyes.
said, when you see he's a mean guy. Oh my gosh, attitude.
I told him I like him. I just hate his classes,
Yeah.
and I think that's why I always go back to his classes, but I still hate him.
Yeah. It's the class.
I need therapy.
Oh gosh, girl.
Making sure my crackers like expired. I be forgetting to check
Oh
them.
yeah, I know. That was so
I thought
funny.
you said
Poison
making sure
it
your
turns out.
crackheads weren't expired.
Exactly.
The day after the expiration date,
Mold.
they turn to poison.
Exactly.
Hey, I'm that serious about expiration dates too, I'm not gonna lie.
For real.
I check them religiously at home.
I don't know.
I can't.
If it's
I
like
don't
milk
know.
or something and you smell it and it's fine, just
No.
drink
Like
it.
I
Unless
can't.
you're pouring it out and it's chunky.
No.
like, just drink it.
Cameron.
If it's even honestly.
One day, if it's the day of, I won't drink
No,
it.
that's what I'm saying.
If it's the day
No,
of,
you
I
know how
won't.
expensive milk is?
Yes,
It is.
do you
I'm drinking
understand
that crap. If it tastes like sour
You
cream,
understand
I don't care.
how scared I am to get sick, girl? I literally won't drink milk. The other day, my milk said it expired on April 7th. It was April 6th, and I did not drink it. Okay, I'm serious. I can't.
I feel
It
it.
smells
I can't.
fine.
There we go.
Drink it.
It's mainly dairy products that I'm that serious about.
All right,
Okay,
everybody's back.
we're ready.
We need to shut up.
Focus.
All right.
That's gonna
So
be
a
hard.
little bit of stuff tonight, not a lot, not even any real math part. More assumptions and kind of ideas. And no, she might need stuff. Well,
This is the stuff that we're gonna be tested on the multiple choice probably.
I
Thanks.
have to look. I would have to look. Yeah. It is material that some of you had before. All right.
Some of us.
But hopefully it will refresh you.
Oh, well, so if I have had this, I can leave.
If you think you can remember it well enough.
Okay.
Does it have to do something with our research methods class?
Yes.
I'm out of
Oh! Except I probably skipped that.
Right,
day.
so this is where everything in the course so far kind of comes together at the end of the course and gets the big kind of reveal for stuff. Remember way back in the course we started talking about things like descriptive statistics.
Yeah.
Right? Then just recently we started talking about inferential statistics. This is where we're going to talk about inferential statistics and where they come from as they relate to probabilities. So one of the things we just recently been doing is sampling distribution of the mean, where you might have some population mean for the normal distribution, and you can calculate what's the probability of drawing a sample of a given size with a certain sample mean, which you just did on this exam. Right? So assume you've got some sample mean that falls relatively far up in the population. Right? You can calculate a probability associated with that little area, right? Or potentially even a larger area there, right? Something associated with that particular end of the distribution, okay? What you can do now, and the whole point for this whole class in many ways, is you can make inferences about your data. So it's one thing to say, what's the probability of drawing a sample of a given size? It's another thing to say, is that particular sample special in any way, right? Like we talk about the idea that you're all, let's say 5 people from the population at large, and the 5 people have an average height of 7 feet tall, right? That's an unusual group, right? Because they fall so far out and the probability is so incredibly low, right? Effectively, what we're going to do here is we're going to make the conclusion that something is statistically significant if the probability of the results is very, very small, all right? So terms that show up here, and it's one people are going to use. Statistically significant. Right? It's one thing to say something significant. People mean it's unusual, it's worth noting, right? It's an interesting observation in some way. When you say statistically significant, that's the way you should all use the word significant anyway.
You are such a
Stickler.
stick in the mud.
Stickler.
Okay, yeah.
Stickler in the mud.
Stickler for the rules.
if something is statistically significant, that means the probability of the results, all else being random, we just talked about the random, is so small that we are going to assume something unusual is happening. Excuse me. Like, for example, a class or two ago, when I was calling the cards, I shuffled them up, right, and showed you the ace of whatever it was, and then said, what's the probability of drawing the ace the second time? I showed you the ace the second time. You all agreed that the probability was so small, I was cheating. Right? Because there's no way you're going to get two aces in a row like that. Right? In that context, mathematically, the probability the results are so small, you would say the probability of drawing two cards that are identical in a row from an otherwise random shuffled deck is statistically significant, because it's way out in the tail of the distribution.
Okay.
Right?
So it means it's not almost impossible.
I would not say almost impossible, because in statistics we put numbers on them. The number we're going to put on it is going to be called alpha.
Oh my.
That looks like sigma.
No.
That looks like a fish.
Oh, there's that fish.
Sigma. This is
Oh
alpha.
It's
yeah,
a
they're
fish.
so different.
Well, sometimes
Oh, wait,
the
that
alpha
is
might
right.
actually be drawn more like this sometimes.
Okay, that's a little bit.
So that was like an infinity symbol.
It
Not
does.
Infinity. Infinity is that.
It's
It's
the
happy.
same.
Alpha this
So
way.
dumb.
It's the same symbol with a bite taken out of
Okay,
it.
wait.
Yeah.
It's a lowercase Greek alpha, A.
Right.
Yeah. Okay.
Right? Alpha is the level at which you decide the results are statistically significant. So alpha's going to have a number associated with it, right? Overwhelmingly in the area of psychology and most sciences, because they adopt the stuff from psychology statistically, alpha's going to be set to 0.05. But it may not be 0.05 all the time. Sometimes it's set at 0.01. Sometimes it's 0.005. Sometimes it's 0.001.
So, if it's statistically significant, is it very, very low and high chance, or high chance, or just low?
Just low. If it
Okay.
is statistically significant, the probability of the results is very, very low. In
Okay.
fact, lower than whatever this cutoff value is.
Okay.
Right? So the idea here would be, if I've got some sample I draw from a larger population somewhere, out in the tail of this distribution, this area is equal to 0.05%. Right?
Okay.
Let's say, for example, there's a z-score. Well, here, what's the z-score associated with the mean? You don't know this one.
0.
0, right? If I say there's 5% in the tail in the C column, so you may still have your tables out, but I know you kept yours for a long time, remember?
Yes, thank you. Thank you.
What is the z-score associated with the probability of 0.05 in the C column? Which is 0. So what's the z-score here?
Between 1.64 and 1.65.
Right? We are going to use that as a 1.65 rounded slightly up. There's a reason for rounding it slightly up, because we definitely want to be in this area. Right? If you take a 1.64, there's a little edge right there. You may miss that little slot right there. Right? We definitely want to be in the top 5%, so we will choose the 1.65. Right?
Okay.
If you get a z-score of 1.65 or higher, notice the z-score goes up as you go out. So you have a z-score of something like 4 out here. The probability in that area is the 0.00003. Right, it's the last number in the table. Right. As your z-score gets bigger, your probability gets lower.
Yeah.
Right? Going further out. If you take a particular cutoff point, and for a z-score in one tail of the distribution, on the right side here, right? If your z-score is higher than that cutoff point, you will then conclude, you will draw the inference that something mathematically is happening that is unusual, like drawing the two aces, right? Or rolling a die and getting a 6 and a 6 and a 6 and a 6 repeatedly without rolling any other numbers. That's not it's not an unbiased die, right? Make sense?
Yep.
That's your alpha level. Okay. This whole area falls into what is called hypothesis testing. Okay. What you're trying to do here is you're trying to make inferences about the real world. Right off the bat, you never actually know the state of the real world. Well, there's some limited circumstances you might, but for our purposes, you never know what's happening in the real world. So, for example, suppose we're playing cards. Suppose we're doing something like poker, right? If you make the assumption that you and your opponent are equally skilled, right? Let's say you play 10 games. How many games would you expect to win? 5, if you're equally skilled, right? If you play 10 games and they win all 10 of them, do you think you're still equally skilled?
No.
Right? Here's a quick question then. If you are equally skilled, assuming you're equally skilled, what's the probability one person wins 10 out of 10 games?
Very low. Very
You
low.
can actually tell me based on the data you've got so far.
0.0.
In other words,
Like
the
working
number of
it out.
trials is 10, the number of successes is 10, the probability, if you are equally skilled, is 50-50. You got a number of trials, number of successes, probability of success, 10, 10, 50%, it's off your table. Binomial, right?
Point 0010. Point 0010.
If you go to the binomial distribution table and you look up 10 trials, 10 successes, with a probability on a single trial of a success of 50-50, you get the 0010. Notice 0010 would be way out here, less than the 0.05. So you would conclude, hey, we're not equally skilled. In fact, you are, if the other person's winning 10 out of 10, statistically better than I am. You are statistically significantly better than I am.
Do you consider cheating at cards statistically better?
Huh?
If they're cheating at cards, would you consider it statistically
That goes to the next question. We'll talk this for a second, right? Suppose somebody wins 10 out of 10, right? If you assume they are equally skilled to you, there are other potential explanations for why they did that well. One is they got lucky, and it's just random, because it's 0.001, that's 1 in 1,000, right? To get that 0010. They may have gotten lucky, hit the 1 in 1,000. Or they may have been cheating, right? Or something else weird has happened. Maybe you had a really, really bad day, right? Maybe your glaucoma was acting up and you couldn't see any of the cards.
Okay, please. Do you have glaucoma?
No, not bad.
Not that you know.
I thought he was projecting.
How's the vision?
You don't know what the real world situation is. You draw a conclusion based on the results of your statistics, right? And if somebody wins 10 out of 10 and you initially thought they were equally skilled to you, you're then going to come back and say, oh, you're cheating. But you don't know they're cheating.
But
All you know is they won 10 out of 10 games, and that's incredibly low probability.
I've got one. I have 9 kids in my class, and 7 of them are left-handed.
Wow.
What's the probability of that?
Very low.
Let's look
I'd
it up.
say.
What's the base rate probability in the population for left-handed? Most people say it's 10%.
Let's see.
Yes, seriously, Google what's the percentage of left-handed. It'll come back right at 10%.
7.5.
Yeah.
Oh, I
roughly
thought
10.
she had the answer.
Right? So if you have how many kids?
9.
9. N is equal to 9.
And it's equal to 9.
Oh,
Number of successes is equal to 7. Probability of a success is 0.10. Go to your binomial table and give me a number.
It's a 0%.
Technically, no.
Oh, well, obviously.
Because-
but I
Because
think that's pretty
the
great.
accuracy of the table only goes to 4 decimal places.
Yeah.
There is a number somewhere out there which is incredibly small, but slightly higher than 0.
They're in elementary school, but they all either have a physical or a mental disability.
Wow.
So that's the underlying.
I
That
wonder
may change
if
the base
they-
rate from the 10%. There may be a higher than 10% probability that people with mental diagnoses may have higher.
Is that, I never knew that was a thing. Is that a thing?
There are any number of subgroupings within the population where people have different handicaps. For example, in
Wow.
common would be if you look at professional tennis players, about 60% of them are left-handed.
Wow. I did not know.
If you're dyslexic, you're more likely to be left-handed too.
Oh my goodness,
There are
learning
certain
so much new
subpopulations
stuff.
that predict certain.
I'm ambidextrous.
Really?
Lucky.
And
Yeah,
I'm,
for
I'm
real?
Here's the
dyslexic.
bottom line, right? Assuming you know the random outcome from the population, so assuming it's random, right? If you get a result that falls extremely far into the tail, you are going to conclude something different is happening.
Yes.
But you don't know that for sure because there is a probability of this event occurring.
Yeah.
So you might say, hey, I think you're cheating, but you don't know, right? There are then 4 possibilities that might happen. This is where you get stuff from before.
Is this what hypothesis testing?
Yes.
Okay.
Okay.
Here's the real world, right?
That's the real
Yeah.
It's a box.
Okay.
Okay.
Your decision is going to be based on the results of your statistical test. Right? You're going to make some decision, right? Either you're going to say, nothing unusual, or you're going to say something is happening. Right? That's a very loose expression. There are specific language in the area. This is the null hypothesis. So the specific language is this is H0, this is H1.
Okay.
Hold up. I didn't draw a big enough box.
What does that say?
I'll get rid of it. The word here is nothing. The word here is something.
Okay.
We're going to go ahead and get rid of it this way. And I'll just put it
Okay.
we'll put it in the statistically appropriate language.
Nothing something.
Nothing is happening is the null hypothesis.
Okay.
Right? So here, I'll put it in the
Well, you know what? I'm still right.
H0 is called the null hypothesis.
Didn't I just see that on the test exam?
No.
No,
No.
not this test. You're likely to see it on the final.
I think I was looking in the book then. Not during the test, of course.
And H sub 1
I went to
is called the alternative hypothesis. The alternative hypothesis is something unusual is happening. One thing might be the person's cheating, right? Another thing might be you've got statistically significant results based on the manipulations of your independent variable in your psychology experiment.
What?
You do an experiment. You want to know, are the results statistically significant?
Oh, okay.
The null hypothesis.
What you said before just like
Sorry.
clicked in my head.
I said it rapidly.
Yeah. It took me. I was lagging.
Okay.
Null hypothesis is nothing unusual is happening. Null hypothesis is I predict these outcomes based on the probabilities of an underlying distribution. Usually it's normal, but it might be binomial. Coming up, it'll be a t-test t-distribution. Coming up beyond that, it'll be an f distribution.
Okay.
Multiple different distributions. They all are predicated on otherwise